Before talking about the code, we will see how we have connected the LED and the button to Raspberry Pi. So to the pin 17, right, we have a connection to an LED resistor, and then we have a LED, okay, and then we have connected the ground here. Okay, this is the connection for LED, and this pin, right, is configured as an output. So that is how the configuration is made in the code. And then we have pin number 27, okay, which we are connecting it to a button. So what we are doing is we are actually taking this, and then we have a switch here, and the other end of the switch we have a resistor which is connected to the 3.3 volt power. So the first pin. So now what happens is, by default this pin number 27 will be in a low state because we will be enabling the pull down on this pin, and this pin actually will be configured as input. That means it will be reading, so it will be 0 by default. And once we turn on the switch, okay, 3.3 volts will be seen on this pin, and if 3.3 volts is seen, we'll glow the LED. And if we turn off the switch by the toggle switch, by changing the position, it reads a low, so that means the LED will be off. So that's how we are configuring this particular connections of LED and the button using the Raspberry Pi. Now we will go to the board and see how the connections are made, and then we will have a look at the code, how it is written. All, we see a Raspberry Pi 3 board here, to which a LED is connected to pin number 17. Okay, and what we are doing is we have a toggle switch here, to which one end of the switch is connected to a resistor, and this is connected to 3.3 volts of Raspberry Pi, the first pin. So that means this actually is a kind of pull up, and then the other end of the toggle switch we are connected to pin number 27. So this is the configuration here, looking very clumsy, right? If you use a cobbler PCB, the connections would be simpler, but as we are using wires, it looks little clumsy, but the connectivity is very simple. So what we are doing is actually, the when the switch is on, okay, you can, sorry, when the switch is on, you can see the LED is on. Now when the switch is off, okay, the LED is off. Again, when the switch is on, LED is on. When the switch is toggled to some other state, LED is off. Okay, so what we are doing is we have written a simple code where, based on the switch toggling, so when the switch is toggled to on state, a pull-up is enabled on Raspberry Pi through this 10K resistor that we connected on the Raspberry Pi GPIO pin. Now, this GPIO pin of Raspberry Pi is configured by default as a input state with pull down. So we will see the code to understand how it is written. As we see here, this is the code that is written for the scenario that we have explained just now, where we are importing Raspberry Pi.gpio, RPI.gpio library as GPIO into our program, and we are also importing time. This is for delay. Anyway, we are not going to use this. We can actually comment this, and then we are actually using the BCM mode rather than the GPIO numbering of Raspberry Pi. So BCM means the Broadcom chip numbering that we'll be following. and we are setting the warnings to false. And here you can see LED variable is set to 17. So this is the pin to which LED is connected. Switch is equal to 27. This is the pin to which we are providing input. Now if you see here, GPIO dot setup of LED comma GPIO out. So what we are doing is this 17th pin we are setting as output, okay, using GPIO dot out, and then switch pin we are setting as input using GPIO dot in. Additionally, if you see here, there's something called pull underscore up underscore down is equal to GPIO PUD underscore down. What does this mean is basically we are enabling a pull down on this pin. So by this, what we are doing is we are enabling a pull down resistor on the pin. So default, when it is an input, it is reading 0. That's what it means. Now we are setting the GPIO output to false. So that means by default, the switch is set to the LED is set to off condition. Now while true means this is an infinite loop where this loop will run infinite times because there is no condition, it is always true. Okay, so if we go here, first what we are doing is we are reading the status of the input pin using GPIO dot input of switch. Okay, this pin number status we are reading and giving to switch underscore input variable. Now if that is read true, that means if the switch is on, the toggle switch is on which we talked, and it provides a pull up to that, the LED is turned on by using GPIO dot output of LED comma true. Okay, else if, which is elif in Python, in the else if, what we are doing is if the condition is false, that means the switch is not toggled, there is only a pull down and it reads only 0. Okay, in this condition we are reading, we are disabling the LED. So if we see, these are the statements which will be running continuously, and once the switch is toggled between two states, right, based on the state that is read, uh, either if condition gets satisfied or else if condition gets satisfied, because it will be only high or low. That's what we'll be reading, right? And then this toggles continuously. So here RPA.GPIO library is required, and then important thing from the previous pull down pull up what we have seen, this is the sorry, in the previous LED blinking code which we have seen, the difference is that here we have set another pin as input with the pull up pull down functionality. So that is the major difference here.